How many oxygen atoms in 5 moles of oxygen gas? We multiply by a conversion factor with equivalent values top and bottom, both referring to a mole of oxygen gas. At the bottom, we need the mole oxygen gas, just written straight like that, to cancel out our given unit. And at the top, we need oxygen atoms. Both top and bottom must refer to a mole of oxygen gas, O2. 1 mole of O2 is the same thing as 2 moles of O. You might have needed 2 steps to do this. Let me show you how you can do that as well. How many O atoms in 5 moles of O2? So you know that 1 mole of O2 is equivalent to 2 moles of O. So that cancels mole O2 out, but it introduces mole O, which is not what we want because we just want O, not mole O. And we know that 1 mole of O atoms is 6,02 times 10 to the power 23 O atoms. So in the second line, we have the 2 steps, whereas in the first line, those 2 steps are just collapsed into 1 step. So if you can see it as 1 step, well, that can save you some time maybe. But if you need to break it down into 2 steps, that's also fine. So let's calculate that. 5 times 2 times 6.02 times 10 to the power 23. And it's actually obvious because it's going to be 10 times 6,02 times 10 to the power 23, which is then 6,02 times 10 to the power 24 O atoms. If you want to emphasize it, you can say O atoms. How many carbon atoms in 2,9 moles of carbon dioxide? If we look back over here to what we did earlier, remember that 1 carbon dioxide molecule contains 1 carbon atom, 2 oxygen atoms. These are equivalent values for carbon dioxide. And 1 mole of carbon dioxide molecules consists of 1 mole of carbon atoms, which is 6,02 times 10 to the power 23 carbon atoms. And 1 mole of carbon dioxide molecules also contains 2 moles of O atoms, which is 6,02 times 10 to the power 23s. Remember that all the values in this block are equivalent to one another for carbon dioxide, and so pairs of them can be used to form conversion factors if we are speaking about carbon dioxide. And that's what we're going to do for the next few questions. How many carbon atoms in 2,90 moles of carbon dioxide? So what conversion factor are we going to use? Pause the movie until you found that yourself. You can look back to that list to help you if you like. Make sure top and bottom both refer to a mole of carbon dioxide, and make sure that you choose the conversion factor such that it's going to be helpful. It's going to get rid of the given unit and introduce the required unit. So we need mole of carbon dioxide at the bottom to cancel away the given unit. We need carbon atoms at the top, and we know that 1 mole of carbon dioxide contains inside it 1 mole of carbon atoms. That 1 mole of carbon atoms is 6,02 times 10 to the power 23 carbon atoms. We do the calculation, we get the answer 1,75 times 10 to the power 24 carbon atoms. How many oxygen atoms in 2,90 moles of carbon dioxide? What's going to be a useful conversion factor? Look back at that list of equivalent values for carbon dioxide and choose out the values that give you mole carbon dioxide at the bottom. So we're still needing a number there. How many mole carbon dioxide is to how many O atoms, not mole O atoms, but O atoms. 1 mole carbon dioxide contains inside it 2 moles. In other words, 2 groups of this number of O atoms. 2,9 times 2 times 6,02 times 10 to the power 23, 3,49 times 10 to the power 24 O atoms. How many O atoms in 19,0 moles of sodium carbonate? So we need a conversion factor with equivalent values top and bottom. And those equivalent values, to be useful, must be mole sodium carbonate. We still need the number there, but mole sodium carbonate must be the unit at the bottom. And O atoms, not mole O atoms, but O atoms must be the unit at the top. So if you need some help in deciding what values, what numbers must fit there, look back to what we said about sodium carbonate. And we're interested in a mole in this case because the question refers to a mole of sodium carbonate, or rather 0.25 moles of sodium carbonate. So look inside this block because this block contains values which are equivalent to one another for this particular compound. Choose out the equivalent values which will be useful in this case. And what you should have said is that 1 mole of sodium carbonate contains 3 moles, which is 6,02 times 10 to the power 23 O atoms. So 19 multiplied by that gives 3,43 times 10 to the power 25 O atoms. How many hydrogen atoms in 6,10 moles CH3COOH? You decide what the useful conversion factor will be before I show you the answer. We need moles of this compound at the bottom and hydrogen atoms, not moles of hydrogen atoms, at the top. So how many moles of this is how many hydrogen atoms? 1 mole of CH3COOH contains inside it 4 moles of hydrogen atoms, which is 4 times 6,02 times 10 to the power 23 hydrogen atoms. 6,1 times 4 times 6,02 times 10 to the power 23 gives us 1,47 times 10 to the power 25 hydrogen atoms. I can just write H, or I can emphasize the fact that it's atoms, write H atoms. How many sodium atoms in 0,250 moles of sodium carbonate? Again, you first try to give the conversion factor yourself. Did you have moles sodium carbonate at the bottom to cancel away the given unit? And have you remembered sodium, or sodium atoms at the top? Now the crucial part. Have you got the numbers right? 1 mole of sodium carbonate contains inside it 2 moles of sodium atoms, which is 2 groups of this number, which is a mole, sodium atoms. Multiply that by 0,25, 3,01 times 10 to the power 23 sodium atoms. How many water of crystallization molecules are there in 3 moles of iron sulfate, which has water of crystallization in it? So again, you choose out a useful conversion factor. Pause the movie until you've done that. We know that that conversion factor must have moles of iron sulfate at the bottom, and we know that it must have water molecules at the top. But what numbers are missing here to make these 2 equivalent to one another for this particular molecule? For this particular molecule, 1 mole of iron sulfate contains 7 moles, which is 7 groups of 6,02 times 10 to the power 23 water of crystallization molecules. We see that 7 over there. 7 H2O. So that's 21 times Avogadro's number, which gives us 1,26 times 10 to the power 25 water of crystallization molecules. Now notice this question says how many water of crystallization molecules. The next question says how many moles of water of crystallization molecules. So now we write how many mole H2O, not just how many H2O, as we had in the previous question. Now it is how many mole H2O. Very big difference between mole H2O and H2O. Can also be a bit confusing because molecules starts with mole, but it's got nothing to do with mole. It's just coincidence. So water molecules is not the same thing as moles water molecules. And here we asked moles water molecules. Are there in 3 moles of iron sulfate? So now what is your conversion factor going to be here? Pause the movie until you found that yourself. Hopefully you did see we need mole of iron sulfate at the bottom. Never just write mole. It must be mole of what? Mole of iron sulfate. And now at the top we need mole water. Not just water, but mole water. So, how many moles water in how many moles iron sulfate? There are 7 moles of water of crystallization inside every 1 mole of iron sulfate. 3 times 7, 21 moles of water of crystallization.